Hello everyone, this is my project presentation for EEE 6512 Image Processing and Computer Vision. My name is Shixiong Jin. First, I want to introduce to image noise. Noise sometimes we can see as a wall that prevents the receiving side to get useful information. It happens randomly and cannot be predicted. Many times, we should use statistical approach to know how often the random noise will appear. To some degree, we should call image noise as multi-dimensional random thing. It is unexpected information that will damage the quality of the image. When we talk about the removed noise in the image, we actually talk about get rid of the dots and sparkle in image. And there are two big kinds of noise. One is impulsive noise, salt and pepper. Another is continuously changing, Gaussian noise. Gaussian noise is probability density function, like the Gaussian distribution. Salt and pepper noise can only take the biggest or smallest value in a dynamic range. The picture here is the probability density of the impulse noise. Here is the mean value, and here is the max value. Just give us a clear picture. And then I want to introduce two pictures. Here, this picture is corrupted by Gaussian noise, by salt-pepper noise. And this picture is corrupted by Gaussian noise. And from these two kind of pictures, we can get a clear idea the difference between Gaussian noise and salt-pepper noise. And here, I just show 4 pictures from left to right. The image density actually increasing. Here is 10%, 30%, 60%, 70%. As we can see, as noise density increase, the quality of the image decrease. The picture get more and more vague. And there are actually two big kinds of image filters. One is linear filter, another is non-linear filter. Mean filter just represent the linear filter, and the standard media filter stand for the non-linear filter. Both the mean filter and the standard media filter are low-pass filters, and the picture here just an interpretation on frequency domain. We can see noise across all frequencies, and image has more low frequency part. From these pictures, we can get a clear ideas. And here, this pictures is just a frequency response of the mean filters. And mean filters. The principle of the mean filters is very simple. It replaces each pixel value with the average value surrounding it. And there is a trade-off we have to make. If we want to remove the noise effectively, we have to enlarge the window size. But at the same time, we blur the image. And here, these two pictures just show us how to replace corrupt pixels. A media filter. Actually, the principle of the media filter is the same like mean filters, but it takes media value rather than mean values. And here, these two pictures just show us how to replace a corrupt pixel values. And here tells us first we need impulsive detectors, and see this determine the noise count and decide to use non-filtering or media filtering. Media filter, here is the equations to S just represent the neighborhood. When the pixel in the neighborhood is odd, it is just the media value we wanted. If it is even, we should take the average of 2 pixel values. Detect the salt-pepper noise. If we want to remove the salt-pepper noise, we first should detect the noise and see how corrupted the pixel is. Here we have 3 equations, and here is a flow pictures to show us details about every process we will go through. And XY represent the location of the pixel. Number 1 stands for the corrupt pixel. Number 0 stands for the clean pixel. Second equation just sum up all the corrupt pixel values. And third equation, we will see how much percentage the corrupt pixel in the all pixel values. And also I will introduce another image technology called image sharpening. Reason we will use image sharpening because when we use a filter to get rid of the noise, we will also lose some useful clean information that will cause the image get blurred. It will emphasize the line or specific details of image. We will use a high-pass filter to get the line information we wanted. We just combine the original image with the edge information. Here, these 3 pictures just show us how to get the line edge information and combine the original image and get the result. And here I will introduce 2 measurements, MSE and QPSNR. MSE is mean square error. PSNR is peak signal to noise ratio. M and N stand for the row and column separately in the image. R stands for the biggest fluctuation in the image. And as we know, the bigger PSNR is, the smaller MSE is, the image will have better qualities. And here is the 2 equations. And later we will use MSE and PSNR to determine, after we use image filters, which kind of filter can get better quality image. A mean filter experiment. And we can see from here the original image, and then we just add some noise into the image, and later we use the mean filter to remove the noise. We can see even the noise is removed, but the image gets blurred better in the image. The image quality is low. The median filter experiment. In this experiment, we can see the original pictures, and we add some salt and pepper noise in the original pictures, and then we use media filter to remove the noise. And also, just like the mean filters, the image is blurred, the image quality is decreased. And then I would just show the picture below, image sharpening. First, the original image, and second, it's the image after we use image sharpening. We can see the quality increase and image just get more clear. Okay, I will just show some program I use in my project. This one, it's a mean filter. We can see input image, we add some noise and use mean filter to get rid of the noise. Very clear. Another technology, image sharpening. We can see the image just get more clear. Original one, after one. And another is a media filter. We can see the original image, we add some salt pepper noise, and the image after the noise is removed. When we down the scenes, we get some result. Here in this project, I just use 2 can noise density, 10% and 30%. And I will also use 2 kind of noise, Gaussian noise and salt pepper noise. Here is the result for the mean filter, and here is the result for the media filter. The measurement is PSNR. As we talked before, if the PSNR is more higher, which means this kind of filter is more better at getting rid of this specific noise. And here we can see the mean filter is good at getting rid of the Gaussian noise, and media filter is good at getting rid of the salt pepper noise. From the calculation for the PSNR, we can see the mean filter is good at removing the Gaussian noise, and the media filter is good at removing the impulsive noise like salt and pepper noise. And later we can detect which kind of noise corrupt the image. We can use specific noise filters. We can see normally when we remove the noise from the image, we will blur the image, which means the image will not be as clear as it before. So we could use the image sharpening to add some edge information to make the picture more clear. Future work. In this project, when I test the mean filters and the media filters, the noise density is not very diverse. But in the reality, actually I just use only 10% and 30%. But in the reality, the noise density will affect the performance of the filter. So in order to get a complete evaluation, in the future, I will use image of diverse noise densities, maybe from 10%, 20%, 5%, 60%, 70%, to get a complete evaluation. So we could see what is the correlation between the noise density and the filter performance. And also the image sharpening even could make the image more clear, but many times will magnify the noise. So in the future, I will try to figure out the best balance. I will just combine the image filter and image sharpening together, try to get a good trade-off, try to make a good balance between these two technologies to see how we can combine these two kind of technologies to get a best image qualities. So thank you for watching.